So if we look at it, one of the things that we talked about yesterday is we talked about the difference between our chemical equation. And we said our basic chemical equation that we've been looking at thus far has always shown those things which are aqueous to be together as a unit. And we saw yesterday that when it came to something like this potassium carbonate that's sitting right here, that potassium carbonate is not going to be together as a unit. We know that it's really going to be made up of two potassium cations floating around in the solution, and also we're going to have our carbonate floating around. We also said that when it came to the aqueous barium nitrate over here, same thing, it's not really connected like this. And also that's true for the potassium nitrate. They're really just the cation and the anion separate from each other. Now the solid, the barium carbonate there, now that does exist as a unit. They are stuck together. So the aqueous substances, we are just going to, once again, try to show them in their true form. And the way that we show them in the true form is that's when we go to this thing known as the complete ionic equation. So this equation right here. And if you look at it, it says an equation that shows the reactants and products as they should truly be seen. And if you go back and you look at the original reaction that we had there, and I'll write it up here on the board so you can kind of see it. But this is the exact same reaction that I showed you in the notes yesterday, where we had potassium carbonate, K2CO3, aqueous, reacting with, what was it, barium nitrate. Barium nitrate. And we saw that this was going to go through to the do-si-do, and we're going to end up getting potassium nitrate, aqueous, and also we got our barium, in this case carbonate, as a solid. And this needed to be balanced, so it was a 2 sitting right here, and you were aqueous as well. So if you look at the notes, what you'll notice is that for this compound right here in the notes, under the complete ionic equation, the only thing we're going to do is we're just going to break it into the ions. We're not going to show it as a unit. We're going to go in here and say, hey, I've got 2 potassium cations, just like I showed you in the notes yesterday. I've got also a carbonate sitting right here, CO3 2 minus, aqueous. Right here, because it's aqueous, and only those things that are aqueous will we do this, I'm going to say, well, that's just a barium cation, Ba2 plus, aqueous. Right here, I've got, in this case, 2 nitrates. So I'm going to say, hey, I've got 2NO3 minus, aqueous. Got that. Now, because I'm running out of space here, I'm going to put the other half, the products, right here. On the product side, I'm going to say, hey, you're aqueous. I'm just going to show you as ions. There's 2 potassium cations floating around in solution. There's 2 nitrates floating around in solution. And because you are a solid, I will keep you together in your true form because you are really stuck together as a unit here. And that's what you're seeing. What you see in the notes, where I show you in this case that complete ionic equation here, all I did was literally just take this thing and break it apart. And if you look at the notes, I tell you right here, only the aqueous ionic compounds will be separated into their respective ions. If it is a liquid or if it's a solid, you are not separating it. Only if it's aqueous. Now, if you can make it to this point right here, and I'm telling you now, especially when it comes to the test, because I'll tell you, hey, you know what? Write me the complete ionic equation, and then I'll ask you to write me the net. If you get to the complete ionic equation, there is absolutely no reason why you should not be able to get to the net ionic equation. Because to get to the net ionic equation, the only thing you must do is you must get rid of what are called the spectator ions. And the spectator ions are just those ions that are just saying, hey, you know what? I'm watching this reaction. I'm not really doing anything here. Because if you look at the reaction here, I have 2 potassium cations originally on the reactant side, and also I've got 2 on the product side. So even right here, 2 right here, and 2 right here. They didn't do anything, so they're considered to be spectators. So typically what I like to do with my reactions is I kind of just put a line right through them. I'll put a line through that one, and I'll put a line right through that. I'm getting rid of that spectator ion. You'll notice also that there's also the spectator ions of the nitrate. So here goes nitrate, 2 of them aqueous, And here goes 2 on the product side that are aqueous. They didn't do anything. They just sat around and watched this reaction. So I'll put a line through it and a line through it as well. And whatever I have left over is going to be my net ionic equation. This is the heart of the chemical equation. It really shows, in this case, the participants of the reaction who actually participated in producing something new. It was the carbonate and it was the barium coming to produce the barium carbonate. Now I put barium first, carbonate second. It doesn't make a difference. If you wanted to have the carbonate first plus the barium cation producing the barium carbonate, that is perfectly fine. The hardest part, I think, for most students is just getting to that complete ionic equation. So what I'm going to do is I'm just going to work through a couple of the problems that you have right here in your notes. So I'm going to scroll down and we're going to take off the screen sharing and I'm just going to literally go through these 2 problems right here just to make sure that we are comfortable here. So I am going to take off the screen sharing. Let me do that now. And let me project up here on the screen the actual problem. And zoom in just a little bit so you can see it here. So the very first thing to keep in mind is that if this was a test problem, I'm going to have this as a standalone problem. So the problems that you had where you had to go through and classify the reaction and balance it, that's still going to be true. So that would happen on your test. But then maybe at the end of the test, I might give you one problem that looks like this here. And I'll say, hey, write the chemical equation, write the complete ionic equation. What is the net ion? What are the spectator ions as well? So the very first thing that you would do is you would look at this problem and say, okay, well, this is a double place reaction. I'll just go ahead and switch partners. Barium will go with sulfate, sodium will go with the nitrate. So I'm going to go over here and just write, in this case, my sodium nitrate, NaNO3. Hey, you're an alkali metal, you're also a nitrate, you're always going to be aqueous. Also, I'm going to end up getting barium sulfate, BaSO4, and you're my solid in this case. I'm going to balance this out, and it looks like I'm going to need a 2 to sit right here. So, for the net ionic equation, the only thing I am going to do, literally, is I'm just going to separate and show my ions. So even when I look at this, this is really made up of barium, and it's made up of nitrate. So I even put right here, Ba2+, and it's also made up of NO3-. That's what's inside of that ionic compound. Now, one thing to point out, this is important, because I always see students make this little small mistake. The state that is sitting here is the exact same state that's going to follow along with them. For some reason, I have students who will say, hey, well, he's a metal, I'm going to make him a solid. He's going to be something. No, whatever state is here is still going to follow because it's still floating around in water. Well, how many of the nitrates are in that? Well, there's 2 right there, so I'll put a 2. And I'm done with that part. I'm moving on to the next part. The next part, I'm just going to say, okay, what ions are making up that sodium sulfate? Well, it has the sodium cation, and also I see the sulfate, SO4, 2-. Okay, well, how many sodiums do I? Oh, I got 2 right here, so I'll put a 2 there. And then once again, aqueous and aqueous, because the states, the exact same states are coming down with this. Got my arrow here. Look at hit, these 2 right here. Okay, well, that's made up of the sodium cations, so Na+, and also it's got a nitrate there, so NO3-. Well, I can see, okay, there's 2, so I'm going to put a 2 here. There's 2 of the nitrates, so I'll put a 2 right here. States are still following. Hey, you're aqueous, and you're aqueous here as well. And then for the other product, that's a solid. So I just write it down. That's easy. I'm just going to put plus BaSO4 solid, and I'm not breaking it apart. I'm just going to leave it right there. You said solids, they exist that way. You make it here and you're done. Because all I need now is, I'm going to ask you the question, what's the net ionic equation? You'll just go in here and say, okay, well, you know what? There were 2 nitrates here, 2 nitrates right there. I'm going to get rid of the nitrates. Or excuse me, the sodiums. I got 2 nitrates here, 2 nitrates right there. I'll get rid of those as well. What's left over? Well, whatever's left over, I'm just going to drop down here and write it as being my net ionic equation, plus SO4, 2 minus aqueous, producing the barium sulfate. And then for my spectator ions, that's easy as well, because whoever I crossed out, I'm going to be my spectator ions. I'm just going to simply say, okay, the sodium cation, aqueous, and the spectator ion, and nitrate, NO3 minus aqueous, the spectator ion. If you want to put the coefficients in front of them, I would never take off points. But the question is not how many, it's just saying who is actually spectating, who's watching this reaction as it takes place. But that's all we're doing. Take the, once again, ionic compounds, break them into their actual ions. If it's a solid or a liquid, you keep them together. So only the aqueous things are the things that must be broken down. Now, question number, or the second problem that's sitting here. Just want to point out, this one I'm not going to do. It's just an example of a double displacement acid-base problem. This one, you can take a look at the answer because the answer is right down here. So both of them, the answers are sitting here. So even if you don't see it right underneath the notes, both of the answers are sitting. The reason why I'm not doing the second one is I want to just do one problem that involves a single displacement reaction in this last 5 minutes of class. Just want to do one single displacement, just so you can see this one. I'm going to make this one an easy problem. I'm going to go with something such as lithium displacing, let's go with something such as, what can we go here? Make it easy. Sodium chloride. And you know what? I'm going to get a little bit more challenging here. I'm going to get magnesium chloride. Still not bad. MgCl2. Now keep in mind, this is a solid. This is aqueous, AQ. Over here. Going through, I'll tell you right now that lithium can displace magnesium because lithium's at the top of the list there. So I'm going to get lithium chloride, aqueous, and then we get magnesium kind of coming off here by itself. Here we go. I'm going to balance this thing by putting a 2 here. So this would be just my balanced chemical equation. The complete ionic equation. Once again, I'm going to do the exact same thing I did in double displacement. We said if you're a solid or you're liquid, you just keep it together. So this is just a piece of solid lithium metal. So I'll just write that down as is. We said, yes.
Don't you need a 2 in front of the Li?
Oh, thank you, thank you, thank you. Woo, thank you there. Once again, perfect. So I need to put 2 there, absolutely. So Li, I put my 2 there. Woo. For the next one, for the magnesium, that one is aqueous. So I'm going to do what we said with aqueous states. I'm just going to write them down as ion. It's made of Mg, which is a 2 plus, and it's also made up of Cl minus. The states are going to follow aqueous and aqueous. And I'll say, okay, 1 magnesium, 2, I need a 2 right there, 2 chlorides. On the product side here, I'm going to do the same thing. You're aqueous, so I'm going to break you apart into lithium, cation, aqueous, and also I'm going to put chloride, anion, aqueous. There's a 2 here, so I'll put a 2 here. And also there's 2 chlorides, so I'll put you there as well. And then on the product side, we're going to have Mg as a solid. And that's it. Now, the only reason I wanted to do a single displacement reaction is I want to make sure that we're clear right here, net ionic equation, because this one is the one in which I sometimes see students get here to the complete ionic equation and they mess up on the net ionic equation. Watch what's going to happen here, because this is a common mistake that I see. I see students who will do the following. They'll say, okay, lithium is right here, and I see lithium over here, and they'll cancel them out. These are not the same lithiums. This is lithium as a solid metal, which I can clearly see is shiny, it's metallic, it conducts electricity, it's malleable, it's ductile, and this is some lithium cation dissolved in water. They are not the same. When I say they are the same, they have to be verbatim, the exact same on both sides, which means that the only thing that I can cancel out here is going to be my chloride here, 2Cl minus aqueous, 2Cl minus aqueous. That magnesium here, that's an aqueous magnesium, and that's a shiny piece of metal of magnesium, which means that that's all I can cancel out. So I have to go down here and say, hey, 2Li solid plus Mg2 plus aqueous going to produce 2Li aqueous, and that's a positive right there, plus Mg as a solid. And then I'm done. And once again, the spectator ions are just the chlorides here. That's yes.
Why do you not need the plus or the minus when the element is a solid?
Because that's just how, it's not an ion. Remember, ions are things that don't have the same number of electrons as they do protons. He has the same number of electrons as he does protons. He's just a neutral element.
Okay.
That's just a solid piece of metal. These are ions right here. Inside that compound, there are ions inside of it. They don't have the right number of electrons and protons where they're equal to each other.
Okay.
All right, let me explain what your homework assignment is going to be, and then I'll take any additional questions that you might have. Your homework assignment is going to consist of going into the worksheet packet. You're going to notice in the worksheet packet that there are, if you kind of scroll down, and let me share my screen so you can see it here. Share right here. Right here, as you scroll down, you're going to see a worksheet that says complete and net ionic equation worksheet. Your homework is just to do the 2 pages. So that's 4 problems that you're going to do. Well, actually 5, I'm sorry. 5 problems in which you're going to work on. You'll just first write and predict what the products are going to be. And then once again, write the complete ionic. Only those things that are aqueous will you separate into ions. Once again, if they're the same on both sides, identical on both sides, you cancel them out and you get your net ionic equation. So you got 5 problems in which to work on.